share the screen and get started. These are questions coming from all classes, so we may be going over the same question that we went over before. I don't know. I don't really care. With a class average of 64, I don't think y'all mind going over a few problems, do you? And we are starting a new unit Monday, so we have until December 3rd to finish that last unit. So we've got plenty of time. So that's why I really thought that going over this homework one more time would help a lot of you, especially those with 60s on your test. Okay, here we go. So let me go to the handy dandy. Say again?
Is the next unit the last test?
I'm sorry, what?
Is the next unit the last test?
What does the outline say? I don't know who asked that. What did the outline say? You got your outline? Okay, somebody, I don't know who that was, but they went quiet on me. All right. So here is the email. Well, the email was up. And 120. And I'm going to start from the back, which means the 7.2 questions. There's quite a bit sent. So I'm going to start with this one, 7.2, 40/21. 7.2, 40/21. The ability to determine the age of some individuals can be difficult if there are not quality government records of birth. Bone growth takes place at the growth plates at the end of the long bones. Once blah, 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 blah. The age at which the growth approximately normally distributed with a mean of 18.8 and a standard deviation of 15.2. So a mean of 18.8 and a standard deviation of 15.2. And they want to know what is the probability that the plates fuse after age 20. And I know they're going to want something after that, so I'm just going to go ahead and answer 3, and I'm going to get, and then they want to know before 16. And let's see if they ask a third question. Okay, and between 15 and 16. So 3 good test questions right here. Between 15 and 16. And let's make sure they're not going to ask anything after that. Okay, would it be unusual? Would it be unusual for the fuse between 15 and 16? Between 15 and 16. All right, so that's the 3 or 4 questions they're going to ask. So here we go. Here is our sheet. And I will do after 20. I'll do that in orange. Now, I'm not going to do those decimals right here. I'm not doing that. I'm not spending time doing that. So I'm going to change this to 19. And I'm going to change this to 15, which is not going to help a lot, but it's going to help a little bit. So 19 and 15 is what? 34? And then 34 and 15 is what? 49? 19 and 15. I think that's 34. I think it is. Somebody check me. And then 49 and 15 is what? 64. And then 19 minus 15 is 4. 4 minus 15 is negative 11, I think. And we don't really care about that because we don't have negative 11 days or whatever, or 11 months or 11 years. So if somebody will check my math there, 19 plus 15, 34 plus 15, 49 plus 15, and make sure those numbers are correct. Somebody give me a thumbs up if you already checked them, please. Somebody, please. Thank you. All right, so they want to know after the age of 20. So 20 is going to be right in here. So if you have an old calculator, you've got to change 20 into a z-score. So that's going to be 20 minus 18.8 over 15.2, and 20 minus 18.8 divided by 15.2, 2.55. That's not right.
Is it minus or plus?
Second entry. Second entry. Thank you. Minus divided by 15.2. That's better. 0.08. And this is 9999. Now, of course, if you've got a newer calculator that can change the mean and the standard deviation, you don't have to do this. Okay, so with the second, the VARS, normal CDF, from 0.08 to 9999. And there's where you would change your mean and standard deviation. If you can change your mean and standard deviation, then you would put 20 right here instead of 0.08. 0.4681. 0.4681. All right, before 16. Well, before 16, I'm going to use green. And 16 is going to be right in here, maybe. And 16 minus 18.8 over 15.2. So we go to our calculator and we do 16 minus 18.8 divided by 15.2, 0.47. So we got a z-score of negative 0.47. Then this is negative 9999. So we're going to go second VARS, normal CDF, negative 99999 to negative 0.47. .3192. .3192. Okay, now between 15 and 16. Well, 16 is going to be right beside 15. So I'm going to take my purple and I want to say 16. There's 19. So 15 is right here. I'm going to exaggerate it a little bit so it won't be right beside the green line. So we got to get 15. So 15 minus 18.8 divided by 15.2 should come out to be negative 1.4. No, shouldn't be that because you can't do z-scores like that. So 15 minus 18.8. So second, enter, second, enter, second, enter. And there's 15 divided by, supposed to be, well, 18. Oh, shit. Sorry. That's supposed to be 18.8, people. Shoot. Then I got to do that whole thing over again. Hold on. This mouse is no fun. Let me clear it. Sorry. I'm so aggravated right now. I can't even see straight. Second quit. Second quit. There. 16 minus 18.8 negative 2.8 divided by 15.2. And that's supposed to be negative 0.18. So that first green one, thanks for saying something. 0.18. And so that's going to be 9999 to 0.18, negative 0.18. And then the second, we'll fix it in just a second. The second one is going to be second enter, second enter is going to be 15 divided by 15.2 negative 0.25. So the purple is going to be negative 0.25. All right, now I'm going to redo my green one. I'm going to redo that because the calculator had 16 minus 8.8. So I've got to fix that. So second vars, and normal CDF, and we're going negative 9999 to negative 0.18. You never have done anything until you work a calculator with a mouse. All right, so that gives us 0.4286. So it's not 3192, it's 0.4286. And the purple is between second vars, normal CDF, negative 0.25 to negative 0.18. That's going to be a very small 0.0273. 0.0273. And is that unusual? Yes, because it's below 0.05. So your answer to the last question, would it be unusual to find somebody between 15 and 16? And your answer would be yes, because 0.0272 is less than 0.05, and 0.05 represents unusual activity. So there's your answers after we found our error. So 0.4681, 0.4286, 0.0273, and yes, it is unusual to find one between 15 and 16 because 0.0272 or 3 is less than 0.05. And if you're wondering where the 0.05 comes from, we've been showing it to you the whole semester. There's 2.5, and there's 2.5. So anything below 0.05 is pretty much going to be unusual. And no matter where it is, 0.02, that's 2%. That's unusual. So the first one, we got it totally wrong. 1717, we got it totally wrong. 0.0135, I don't know why we got them wrong. So somebody help me out. Did I type in something wrong, or why we got totally different numbers?
The thing that I saw in this question is one of the numbers is in months and not years.
I'm sorry, say again.
One of the things that I saw in this question is the 15.2 is in months and not years. The rest of the numbers are in years.
Well, just forget it. I'm not going through all that. That's just a bunch of bull crap. I'm sorry. That's ridiculous. Thank you for bringing that up, Mr. Brooks. That's ridiculous.
I realized it when I did it, but when you started doing it, I just didn't think it meant anything.
That's ridiculous. All right, so you got to change 15.2 months into years. So somebody take 15.2 and divide by 12. That's ridiculous.
Yeah, I tried to do that.
I'm sorry. I'm showing my temper here, but that's ridiculous. 15.2 divided by, let's see, that's what? Divided by 12. That's going to be 1 and something years. What is it? 15.2. 15.2 divided by 12. 1.26. So a standard deviation, that's ridiculous, of 1.27. So mark out that 15.2 and change it to 1.27. No wonder people sending this question in. It's a stupid ass question. I'm sorry. That right there, that's kind of like, you ever met somebody that you say something to the effect, oh, it's going to take 6 hours to do this. Well, actually, it'll take 5.35. You ever met somebody like that? That's the type of question this is. That's ridiculous. So I'm going to change this. I'm going to go through the first part of it because it's ridiculous. I'm not going through the whole question again, but I'm glad that you found. I knew something was wrong when my numbers were not right. I knew something was wrong. Thank you, Mr. Brooks, for bringing that up. I didn't even see that. So let's redo it. I'm not going to redo the whole question. But mean is equal to 18.8, and the standard deviation now is converted as 1.27. And now we're going to put 18.8 here. And I got to go through and add all this because I'm not going to ask y'all because y'all don't talk to me. But 18.8 plus 1.27 equals 20.07 plus 1.27, 21.34 plus 1.27, 22.61. Do the other side, 18.8 minus 1.27, 17.53 minus 1.27, 16.26, and minus 1.27, 1.27, 14.99. Now I'm going to draw the after 20, I'm going to draw that on here for you. So let me put this up. A after 20. Well, that's going to be right in here. And that's going to be 20 minus 18.8 divided by 1.27. And that's going to go to 9999. The second part is before 16. And that's going to be right in here. $16 minus 18.8 divided by 1.27, and that's going to be to negative 9999. And then between 15 and 16 is going to be right in here, and I'm just going to color it solid. And that's going to be 15 minus 18.8 divided by 1.27. And that's going to be between these two z-scores here. And you can see that the purple is well under the unusual. So it pretty much answers itself. So I apologize for that error. But like I say, that's kind of a sneaky way of tricking a student, because it tricked me. So it's really, that's not a test question. I would not put that on a test knowingly, because to me that's sneaky, and I don't agree with that. All right, so that's 740. That's why people sent 740 like 3 times. All right, 739. Let's see, here's 7.239. 7.23920. 7.23920. 7.23920. I've actually seen this one on the test, so I know this one is on there. And you got a mean of 1,252, what is it, chocolate chips. Now, do we need to change the chocolate chips to semi-chocolate chips or half chocolate chips? Good gracious alive. Standard deviation is 129. And A is going to be between 1,000 and 1,500. A is between 1,000 and 1,500. B, we'll do that in green. B is going to be fewer than 1050, less than 1050. C is more than 1200. And we'll do pink 1450. All right, here we go. Oh, I'm sorry. I forgot to get my forehead and ceiling fan. Hold on. There we go. Everybody good? All right, here we go. So the orange is, we got to do our bottom first, and let's make sure we don't have to convert any chocolate chips. 1252 in the middle. And I'm going to have to do this. I can't look at the screen that way. I'm sorry. Let's go with 1252 plus 129, 1381 plus 129, 1510 plus 129, 1639, 1252 minus 129, 1123 minus 129, 994 minus 129. And somebody please check my math, please, so I don't go all the way through the problem and have a error. Okay, and this is positive 9999, and this is negative 9999. Okay, so where is above, or I'm sorry, between 1,000 and 1,500? Well, 1,000 would be right in here. Let's see, halfway, that'd be 60. Yeah, I'd say right in here is 1,000. And 1,500 be right in here. Now I'm just going to show you this because I think now y'all know how to do an old calculator. So 1,000 minus 1252 over 129, and then 1,500 minus 1252 over 129. So if you got an old calculator, you can be calculating those. But those of you with a new calculator, I'm just going to do it with a new calculator. And I'm going to do second bars and normal CDF. And I'm going to go from 1,000 to 1,500. Not 15,000, dork. And I'm going to put in the mean of 1252 and the standard deviation of 129. And see, if you got a new calculator or a newer calculator, it'll do everything for you. 0.9474. 0.9474. And that's the area between the orange marks. Okay, now let's do less than 1,050. Less than 1,050. So 1,050, I don't know, that's 1,000. So 1,050, let's just say it'd be right about there. Less than would be to the left. So 1150 or 1050. 1050 minus 1252 over 129. And then we're going to use negative 9999. But on a newer calculator, you could just type everything in. So second vars, normal CDF, negative 9999 to what? 1200 or 1050? And paste. 0.0587. 0.0587. Now let's do the purple. Less than 1200. Well, 1200 is going to be right about here. So that's going to be 1200 minus 1252 over 129 for the older calculator. And you're going to again use negative 9999. So let's go to the calculator. And you can actually just use this again. Second, enter. And negative 9999 to, oh, we got to go the other way, 1200. Sorry, that's this way. More than 1200. So we got to go to positive 9999. So I'm just going to hit second vars, normal CDF, and we're going from 1200 to 9999 and paste. Wait a minute. Let me clear that. Second vars, normal CDF, paste, 0.6566. 0.6566. And now it says find 1450. Well, 1450, they're going to assume that you're reading from the left. 1450 is somewhere in here. And they're going to assume you're reading everything to the left. If it doesn't specify, they're reading everything to the left. Left is by default. Write that down. Left is by default. So if you don't have any indication of, which direction, left is always default. It's always assumed to be left. So I'm going to do 1450 negative 9999 to 1450. So that's going to be second vars, normal CDF, negative 9999, because we're reading the left, to, what do we say, 1450? Excuse me, 0.9376. 0.9376. And hopefully we got these answers correct since we didn't have to change the chocolate chip into a Skittle. Okay? I'm sorry I'm being sarcastic, but that question pissed me off. I'm sorry. Oh, let's just throw months in here. Anyway, let's see. Our first one is 0.9474. 0.9474. And the next one is fewer than. We got 0.6566. Okay, well, I must have rounded wrong or something. Let's see, is that, yeah, purple should be 6566. No, fewer, okay, fewer than 1050, 0.0587. 0.0587, I skipped one. There we go. And now 0.6566. And the last is the, let's see, service says round to the nearest integer. That'd be the 94th percentile. That's it. 4 good test questions. Those are 4 good test questions. And that's why that one's on the test. And this dumbass question with convert months to years, that's not on the test. Believe it or not, I don't try to trick y'all. I don't know why the book tries to. Some of them are okay, but I ain't gonna say nothing else. 7.233/17. 7.233/17. 7.233/17. 7.233/17. And let's see if it is a test question or a decent test question. Yes, this one I like because they're very short and sweet. Assume the random variable x is normally distributed with a mean of 55 and a standard deviation of 5. And you need to switch that 5 to months in the year. Find the 5th percentile. So the 5th percentile is 0.0055. 0.0500. Find the, that's how percentile is written right there. That's how percentile is written. Find the 5th percentile. So let's see, 55, 60, 65, 70, 50, 45, 40. Now, where is 5% on here? 5%. You're reading from the, let's make sure that's, yeah, percentiles, that's to the left. It's defaulted to the left when you do a percentile. So 0.05, there's 2.5, and half of this is 6.75. So 6 plus 2 is 8. So this is about 9 right here. That's about 9%. So we want 5%. So we need to back up. This is 7. So we need to back up, or 6.5. We need to back up from 9 4 places. 1, 2, 3, 4. Well, somewhere in here. 4 places. I think that'll be it right about there. So by the empirical rule, the 5th percentile is going to be around 46 or 47. 46 or 47. Probably closer to 46. So, first of all, we got to get inverse norm involved because we got an area and we need a z-score. Second bars, inverse norm. Now, you can type everything in if you got a newer calculator, but I'm going to do it old school because you may need to know how to do this. So, the area is 0.0500. And for the old calculators, you can't change 0 and 1. You just type it in. And left is default. So that z-score is negative 1.64. So this z-score for 40 or for 0.05, the z-score is equal to negative 1.64. So we got to use Oz plus mu. We got to find the test score. And X is the test score. X is equal to Oz plus mu. Now, if you have a newer calculator, you don't have to do this because it'll spit it out. When you put that mean and standard deviation in there, you're going to get your 46 or your 47. So equals 5 times negative 1.64 plus 55. So 5 times negative 1.64 plus 55. 46.8. Wow, I got it right in the middle. 46.8. I said between 46 and 47. So there you go. And that's how you do that question. So your answer would be 47 if they asked for an integer. Let's see if they ask for a whole number. Let's see. Round to 2 decimal places. I can't remember what I got. Hold on. 46.8. And that's how you do that one. Okay, let me keep going. I'm trying to go. Let's see. That's 8, 9. That's 9 test questions I've went over. Let's see what this one is. That's 33. 25. 7.2 25/15. 7.2 25/15. And this is a test question because it's short and sweet. And I'm just going to cover up all that. I don't want you to. All right, here's the question. Mean of 45 and a standard deviation of 9. And they want to know what is the probability that your test score or that your age or that your blah, blah, blah is going to be less than 41. Less than or equal to 41. So the first thing you do is 45, 54, please check me, 63, and 72. 45 minus 9 is 36. 36 minus 9 is 27. 27 minus 9 is 18. I hope somebody check me. And take our orange pen. 41. Where is 41? 41, let's see, half of 9 is 4. So that's 40.5 right there. So $41. And of course, if you got an older calculator, you're going to have to use the 41 minus 45 over 9. And that's going to be that z-score right there. And it says less than, so that's negative 9999. So you're trying to find this orange area right here. So take your handy dandy calculator and second VARS, normal CDF, negative 9999. And I'm going to use the new calculator, 41 and 45 and 9. 0.3284. .3284. And that takes care of that. So it looks like this and .3284. And we still got time to do another one. So that's about 10 questions. I think there's, I don't know how many is on the test, but I think 20 or 25. Next. That was 25. Here's 23. 2314. 7.2, 2314. 7.2, 2314. And again, this one's a good one because it's short and sweet and you don't have to convert anything. So mean is 50. Standard deviation is equal to 7. And P, probability, what is the probability that your age, your test score, blah, 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 is greater than 39? So that'd be 50. That'd be 57. That'd be 64. That'd be 71. That'd be 43. And that'd be 36. Please help me. And that'd be 29. Please make sure those are correct. And we want to know what is the probability that our score or age or whatever is greater than 39. Well, 39 is right in the middle here. So if you got an older calculator, that's going to be 39 minus 50 over 7, and you're going to go to 9999. And that's going to be second bars, normal CDF, and that's going to be 39 to 9999, and we got a 50 and a 7. 0.9420. 0.9420. And that's your answer. There it is, 0.9420. And one more for good measure. That'll take us to 19 right here. 7.2, 19/12. 7.2, 19/12. And it says, oh, this is the one I do not like. Z to the 11th power. I mean, Z subscript 1100. Now, why did I write it like that? Because this one pisses y'all. Okay, this is a complement. What's the problem? Mute your mic, please. This is a complement. So what they're really wanting the area, the Z-score for the area of 0.8900. Okay, I've never seen this before. Okay, when you want an area and a complement, it would be P hat or P like that with a 0.1100. I've never seen this before. So I don't know what this book is doing. I don't know if it's making up its own stuff as it goes, but I've never seen that before. So 0.8900. So that means the area to the left is 0.8900, which is going to be like right in here. 0.8900. That's what they're wanting. And all we're going to do is inverse norm 0.8900. Now, they don't give us a mean or a standard deviation, so we assume it's 0 and 1. And that's going to be second vars inverse norm 0.8900. And we just assuming 0 and 1 and paste and 1.23. That should be your answer. This is not a test question because, like I said, I've never seen it before. I've never seen it written like that. 1.23. Okay, so that's at least 10 or 12 questions that you might see on the test. So hopefully that'll help you, and I'll send this to the other Math 120s also because they need it too. They're not the only ones that's screwing up this test. So let me go ahead and call the roll and get that out of the way, and because I don't want y'all to get dropped. The way Tri-County's dropping people left and right, I'm surprised y'all are still here.
Priority 1 message coming in on
146.323. Yeah, we have to do that. Every time we log on, we have to do that.